Good morning,
Good morning. Good morning.
good evening, good afternoon, whatever from where you're joining the presentation. This is Ahmed Moataz from UE Systems. And today we are going to start our presentation. Our topic today is condition-based lubrication best practices using ultrasound technology. So today's topics, we will cover the ultrasound technology. We'll see how the technology works and where we can use the technology and why industries use it. Also, we'll see how it can be implemented and how maintenance and reliability professionals apply the condition-based lubrication program. And also, we'll give you a quick brief about the latest trends in the condition-based lubrication in the IIoT. Let me first brief you about UE Systems. We are a US-based company, started in 1973. We are working in the ultrasound condition monitoring field. We are manufacturing the ultrasound tools and also supporting our customers with training programs like Category 1 and Category 2 as per the ISO and the ASNT. My name is Ahmed Moataz. My background is a mechanical engineer. I'm working in the field of condition monitoring since 2010, and I'm working in U Systems since 2015. I'm taking care of the Middle East region. First, let me introduce, or let me first highlight what kind of ultrasound technology we will be discussing today. As we know that there are different types of ultrasound. Let's talk about the first one. We call it the pulse echo ultrasound. This kind of technology is a technology used for the medical uses, also used in the industrial inspection. The pulse echo ultrasound, basically, the idea and the philosophy of working with this technology is based on the sending and receiving high frequency waves, so it can draw for you and show you the exact image inside the organs, or if we are using it for the inspection on the industrial inspection, it can show you the thickness and so on. So basically, this technology or this division, we call it pulse echo. It's a sender and receiving technology. The second one, which we call it the power ultrasound. Power ultrasound is a sender technology. So the first one is a sender and receiver. The second one is a sender only, which used in different applications like cleaning, welding, and different purposes. The third one, which will be our topic today, which is the airborne structure-borne ultrasound, is a technology which only receive sound. So we're talking about the technology which only receive sound. The airborne structure-borne ultrasound basically can receive the sound in which is high-frequency sound, which is non-audible sound above our audible range. The high-frequency ultrasound can hear frequencies from 20 kilohertz and above, and our audible range can hear frequencies from 20 hertz up to 20 kilohertz. So basically, the ultrasound technology is very high frequencies, non-audible for us, very weak waves, very short waves as well, can be captured by the ultrasound tools and can be heterodyned to be a low frequency, to be audible frequency for us. So basically, the ultrasound tools can capture these high frequencies and convert it into low frequency to be audible and to be easy recognized. So we use the ultrasound technology to listen to the frequencies which is non-audible to us and heterodyne and translate this signal to be audible for us, as well as the deviations from the any change in the decibel value or in the if you are using it for trending or for troubleshooting, it will help us to detect and to know what kind of problem and the deterioration rate as well. So we only hear sound at frequency, selected frequency. We can listen for the earliest symptoms of the acid failure using the ultrasound technology. So it's very simple and easy to use the ultrasound technology. Also, it's very versatile. We can use it in different applications, and it's cost effective. It can show you the savings and can show you the ROI, or the return on investment. So we applied ultrasound in two methods or in two ways. The first way, we call it the airborne ultrasound inspection, and the second one, we call it the structure-borne ultrasound inspection, based on the application which we are applying on it. So some applications will require structure-borne testing, like the contact sensors or the contact modules, and some applications will require to be listened using the airborne sensors or modules. It depends on the phenomena of the sound or the high frequency sound which we are searching for. So basically, where we can use the ultrasound technology, what kind of applications we can use the ultrasound technology. The ultrasound can help us to listen to the friction. Ultrasound can help us to listen to the turbulence. Also, the ultrasound can help us to listen to the ionization and the impacting as well. So basically, today we are going to focus mainly on the friction-related problems, which can be sorted in the condition-based lubrication and the condition monitoring of the rotating equipment. All these applications are the ultrasound applications. That's why it's a very versatile technology which can be applied in different applications. So mainly we will be focusing today, our topic will be for the condition-based lubrication for our rotating equipment. So the bearing condition monitoring and condition-based lubrication, let's start the story from the beginning. If we are talking about the bearing, rotating and the rotating equipment condition monitoring, back to the basics where we can allocate the ultrasound. So basically the ultrasound is a technology which can help me to detect the problems in an early stage. So now I'm talking in a predictive tune. Yes, the ultrasound can help me in the PF curve. I can see the problem in an early stage, and I can see the problem before it happened, or I can see the problem in a very early stage, and I can even have a maximum time for planning before the failure happened. Okay, so the ultrasound not only will act as a predictive maintenance tool, the ultrasound can act as a proactive tool as well. So now we are talking predictive, let's talk proactive. So predictive, we can detect the problem in an early stage. Proactive, we can eliminate the problem to happen or extend the time between installation and the potential of failure. So how the ultrasound can act as a proactive technique, the ultrasound can help me to detect and to avoid the lubrication related problems, especially in the rotating equipment and especially in the bearing, which is grease-based bearing. And this will be our topic today, how the ultrasound can be applied to be a proactive technique and also to help me to increase the time between the I and the P, and also how it could be applied for the condition-based lubrication. So I'm not sure or no, but maybe some of you already heard these phrases before. Like when I ask some people, how do you grease your bearings? What strategy you are following? What's the lubrication strategy in your plant? I've heard a lot of things. Some of them, they know that we have over lubrication challenge. We use way too much grease here. We send motor to be rebuilt when it is full of grease. We have the experienced guy who have more than 10, 20 years experience, so he know what he do. We have many failures related to lubrication. We don't know when the last time this was greased. Most of the time, we just pumping until we see the grease coming outside from the drain. Now we can say that's enough. All these kind of answers based on the strategy which we are following, it means that we have problem or we have a challenge in maintaining the quantity in the right time, the right quantity in the right time. That's why reference to SKF, this average came from SKF Maintenance and Lubrication Toolbook, page number 5. They are saying that 36% of the bearing related failures come from poor lubrication, 14% come from contamination. We are talking about 50% of the bearing failures can come from the lubrication related failures. Another reference from SKF as well, they are saying that up to 80% of the bearing related failures can be traced as to be a lubrication or poor lubrication practice. So when we are talking about lubrication, we're not talking about only lack of lubrication. We can also talk about over lubrication, and also we can talk about contamination. So today's we will cover as much failure modes or not failure modes as much as aspects which can affect our lubrication program as well. So basically, lubricant contamination is a big player. Unsuitable lubrication also, long time without renewing the grease, insufficient amounts. So we're talking about over and under lubrication, and also contamination will be a big player and also a big percentage which can affect our bearings and affect our lubrication program, and also it's more behavior aspect and also more culture related aspect, not a technical related aspect, the lubrication contamination. So let's start from the beginning. As we know that the lubrication is a very precision process. While we are greasing our bearings, we are greasing our bearings with grease. The grease contains oil, which we call it the base oil, and the thickener. So we are talking about a grease is a structure. Once the grease entered inside the bearing, what will happen? the base oil will start to be formed on the between the ball, inner race, outer race, and cage. And this oil film, which is formed, can be measured from 2 to 3 microns, which is a very, very small, thin layer. If we are talking about one strand from hair, it can we can see it under the microscope equals 75 microns, which is relatively very big difference between this thickness and this thickness. So we're talking about a very precision process. So based on this precision process, we want to maintain some grease inside the bearing, and thickener goes inside and start to spread the base oil, and the base oil start to make these 2 to 3 microns around the bearings. So it's a very precision process. Cannot be deal I cannot deal with it like just pumping some grease and that's all. That's why we can see in our plans some bearings face the over lubrication challenge and some bearing face the lack of lubrication challenge. So at the end, both of them are a big problem for us. So where we started the lubrication, we can start from the behavior and the culture part, which is how we organize our lubrication and how we grease or re-grease the bearings. Is it based on just on typing the grease, the date, the last time I greased this bearing, just typing this on the asset itself, on the motor itself? After sometimes what will happen due to the contaminant, due to the environmental issues, it can be also removed. So that's why it's not only about having the grease, greasing the bearing and just typing down the type of grease or typing down the date which the last time I greased the bearing, and that's all. We have also a lot of failures can be related to this kind of behavior and culture mistake or problem. So usually from the greasing best practice, we can grease the motor while it's operating to make sure that distribution of the grease inside the bearing and keep the grease gun and the connector clean. We're talking now about the contamination. We can use a manual, not a battery powered grease gun, just to make sure that I will be greasing little at a time, and we'll make sure that the pressure inside the bearing will not be too much. And I will make sure also to open the drain during greasing just to release the extra pressure. Slowly add grease to the bearing. So adding grease too quickly, especially with the automatic gun, will overpressurize the bearing housing and can cause the failure below, as we can see. Use an ultrasonic sensor to listen to the bearing and decide if it needs lubricating. If it does not need lubrication, add grease while continue to listen. And this we will be discussing it now. So now if we're talking about the best practice, we are talking just about some simple points or some simple procedures could be followed just to avoid having this kind of problem. So what about the grease incompatibility also as well? Grease incompatibility can affect the bearing lubrication program, since grease have different viscosities, additives, and thickeners, which can be incompatible. This incompatibility can lead to hardening or softening the lubricant and bearing failure. So one of the things also we should take care of, which is the grease type, what kind of grease we are using, what kind of temperature it can sustain, what kind of operation, what kind of speed, and so on, what kind of bearings as well. So it depends on the many variables. We have to make sure that we are using the right grease as well. After that, we can follow the color coding procedures. And what is the color coding? Basically, it's a very simple process of just adding or changing the colors of the grease nipple cover or the grease fitting cover with specific colors related to the same colors which will be used for the grease gun. So I can use this fitting cover with specific colors, and I will match the same to avoid contamination and also to make sure that I'm adding the right grease. So now we are talking about 2 points. Number one, I will avoid to have a contaminated grease or contaminated lubricant inside my bearings. At the same time, I will match the same color with this grease gun. So I will make sure that I'm using the right grease gun also every time in the right bearing. So whatever the bearings having a cover, blue covers, I will be using the blue one. I will make sure that I'm adding the right lubricant here and there. It's very simple to be followed, and also it's very simple not to be forgotten by any one of our team in our plant. Okay, so if you want to follow a world-class standard for the electrical motors, so use the correct oil level and lubricant ID tag for the oil pass lubricated, color-coded grease caps if grease lubricated, no exposed wiring, conduit in good condition, and clean exterior fan is working condition. So clear and color-coded tube, it's very simple. Protective cap on the coupler and also in working order and also will be clean. So basically, to determine the appropriate course of action, it's crucial to have a clear understanding of our current location and our desired destination. So first, we want to know where we are, then to know just how to go there or where we want to go. So basically, if we are following the time-based lubrication, I can tell you that it's a good practice, but it's not the best. So the time-based lubrication, basically, I'm just following numbers or some calculations based on the number of hours. These recommendations came from the manufacturer, came from the bearing manufacturer, whatever. I'm just making some calculations to take out the exact amount of grease and also the exact number of hours or the frequency of the greasing these bearings. So we are this philosophy, this strategy is based on the calculation, is based on numbers, based on speed, based on temperature, based on a lot of things, and also it will not be 100% efficient. I'm not 100% sure that I'm adding the right amount in the right time. That's why following the time-based lubrication, still we face some problems related to over lubrication and some problems related to lack of lubrications. So basically, we use the ultrasound to, instead of asking our timesheet, we go and ask our bearings. The condition-based lubrication will help us to listen to the condition inside the bearing and to listen to what's happening inside our bearings. So basically, using the condition-based lubrication will help us not to see these kind of problems anymore, will help us also to avoid having lack or over lubrication in our rotating equipment. So the ultrasound devices can help you to know when and how much, which is a very important questions, when and how much. So it will let us know when when the bearing need grease and how much amount of grease is needed, and also will let us know if the bearing is over greased. So we will be greasing as per the condition. This is the most important part we are talking about now. I'm greasing my bearing as per the bearing condition. When the bearing asks for grease, I will grease the bearing. If the bearing is not asking for grease, I will not add grease. So basically, this is a sound file recorded while greasing one of the bearings. I'll just play the sound. So now the ultrasound technology helped me to listen to the friction level, to listen to these high frequency waves, sound waves, after converting it into a low frequency waves, helped me to listen to the friction level decrease during greasing the bearing and to listen to what's happening exactly inside while greasing the bearing. So usually we use the ultrasound sensor, like the structure-borne one. We don't use the airborne anymore in the structure-borne inspection, like the rotating equipment. So we use the structure-borne sensors on the both bearings. Let's say, for example, if we are talking about an electrical motor, we use the sensor next to the grease fitting in the inboard and also in the outboard of the motor. So usually it's not recommended to put the sensor on any fan shroud or cover or cooling fins, because basically we want to listen to exactly what's happening inside the bearing. So it's highly recommended to use the sensor on the motor housing itself or next to the grease fitting or the grease nipple. So make sure also to use the same location, mark the spot for future readings, and also make sure that the surface is clean, since we want to touch without any extra mediums between the sensor and the motor as well. So the challenge now, if we are using the time-based lubrication, the time-based lubrication basically can tell us when to lubricate and how much amount of grease. The manufacturer will mention this in his, for example, data sheet. However, applying the condition-based lubrication will help us to know when to lubricate and how much amount of grease by following the next slide procedures. Usually, building the condition-based lubrication program, it's highly recommended to start with a baseline. So starting with a baseline is where we start our lubrication-based, condition-based lubrication program. So the baseline will be the reference decibel value, which will help us to be trended and will help us also to follow this change in this decibel value. So basically, If we are using the condition-based lubrication program, I will start to trend my baseline and trend my baseline decibel, and will take the action based on the change in the decibel value on the change of the baseline. So setting the baseline, I have many options, or I have many types of setting the baseline. The first one, I can make a comparison or a comparative method between two similar bearings. I can also use a baseline during lubricating one of the bearings. I can go to a bearing which need to be lubricated, will start to lubricate the bearing until I reach the lowest dB. At that time, I will save it as a baseline, which is also a recommended way of setting the baseline. Or if I have a new bearing, I will start setting the baseline from the first reading, which will be locked to the software. So if I don't have a new bearing, if I don't have a similar bearing, so I can use the setting the baseline during lubrication. So I will just assign one of the motors to be greased today, which need to be greased today as per the timesheet. Yes, I will grease this bearing this period. So I will just go, I will mount the sensor, I will start to grease the bearing, I will reduce the decibel value to the minimum, and then we'll save this number as a baseline. So I will start grease the bearing until it reach the lowest dB value, and will make sure I'm just not over greasing the bearing, because if I'm over greasing the bearing, the decibel will start to rise again. So I will just reach the lowest one, and we'll just set this decibel value as a baseline. After that, we may face an effect during setting the baseline. We call it the Panadol effect. What is the Panadol effect basically? When establishing the baseline, it's important to exercise caution and be mindful of the Panadol effect. What's the Panadol effect? Let's see first what the Panadol do for us. The Panadol is known for providing a temporary relief. So what is the meaning of temporary relief? It's just a relief for some time, for some hours, for some minutes. It depends on the type of the problem we have. So whatever the headache, for example, I have a headache, so I start to take a Panadol, then the headache will disappear. But still, if I have the same problem, the headache will come again. So when we are greasing our bearings, the faulty bearings, the same effect can happen. The grease will reduce the friction and fill in any microscopic faults, resulting a decrease in the bearing friction and decibel levels for some time. So usually it's highly recommended while setting the baseline to wait from 2 to 5 minutes before confirming the baseline sound and the baseline decibel value. For example, I went to the motor drive end, I greased this motor drive end, and I dropped the decibel to 20 dB. And then I visited the non-drive end, and I dropped the decibel, for example, till 30 dB. Before saying I have a 30 dB non-drive end baseline and 20 dB baseline here, no, I will say I will just wait 2 to 5 minutes, and then we'll recheck again both bearings, and we'll see the change in the dB. If the decibel value come back again to the normal decibel value before greasing, so now I can suspect this Panadol effect happened to this bearing, and I can start monitoring and make some analysis on this bearing. Maybe I have a problem which showed me this Panadol effect. So after setting the baseline, we will start to follow the action decibel levels for lubrication, which shows us when to re-lubricate the bearings. So number one, I will already set my baseline. After that, I will start to monitor and trend the bearing decibel value. Once I see an 8 decibel increase above the baseline, now I have a lubrication alarm. And when we are talking about the lubrication alarm, we are talking proactive. We are not talking predictive. So no need to panic. We don't have a failure yet. We don't have a big problem in the bearing. We just want to re-lubricate the bearing. Once I find 16 decibel above the baseline, at that time I have a suspected visual fault. So now, yes, we are talking predictive. And now I can use the ultrasound analysis. I can use the vibration analysis to pinpoint what kind of problem I have. Once we find the 35 decibel above the baseline, at that time I have an extreme damage, or I have a big failure inside the bearing, and also it will be shown before even 35 plus. So the procedures will be as simple as follows. I will start setting a baseline. I will follow the action levels and the condition-based lubrication trending, and then I will lubricate when it's required. Let's take a case study. This case study was done in one of the plants, and this case study, they used time-based lubrication. It's a groove ball bearing, and they used to grease this bearing every 3 months with 20 strokes. as per the manufacturer recommendation. So this was the plan for the lubricating the bearing time-based. We visited this bearing after 3 months from the last time they greased the bearing to set a new baseline and to start the condition-based lubrication program. We found that the decibel value was before greasing was 46 dB, and then they used to put 20 strokes. We start to lubricate the bearing and we decrease the decibel value during greasing. The friction decreased from 46 to 39. And now we found that we reached already the lowest decibel value we can reach. We were surprised that we only added 7 strokes, not 20 strokes as before. And after monitoring and trending this bearing for some time, even the grease quantity were reduced, and also we optimized the right amount every time greasing this bearing. Another case study which is more interesting for me, since this case study also shows us how the ultrasound can help me to avoid over lubrication and to eliminate the over lubrication process in our plant. In this plant, they used to put 15 stroke inside the bearing every 1 month, and the initial decibel value was 27 dB. We went after 1 month from the last time they greased the bearing, and we put the sensor, we start greasing the bearing, and the decibel value should be decreased. No, the decibel value increased. So after adding 4 strokes only, we found that the decibel value increased from 27 to 30, which means that we are over greasing or over lubricating our bearings. So the ultrasound will not only help you to add the right amount, the ultrasound also will help you to avoid the over greasing and over lubrication related problems. So over lubrication will give you a sign of dB increase during lubricating the bearing. Lack of lubrication will increase the friction while you are monitoring your decibel value frequently. So you will be lubricating as per the bearing demand. You will be listening and monitoring the friction levels during lubrication. If you have any other problem than lubrication, you will know. So now no need to anymore to grease blindly. Now you can feel and also you can hear what's happening inside the bearing while greasing. Using the software of the ultrasound technology also can help you to see the alarm levels and will help you also to see where this is just a proactive alarm. This is a predictive alarm. So now the 8 decibel above the baseline means that I just need to lubricate the bearing. 16 and above, now I need to recheck this bearing to record the sound for this bearing, to make some analysis for this bearing. Even I can view it in vibration as well. Also, we can see that we can apply the calculations which will help us to see how much saving we can save from the grease after using the condition-based lubrication. In these lubrication fields, we can see that planned strokes, I can add this as an input in the beginning of setting my route. And every time I'm greasing the bearing, the ultrasound, I can log this value to the ultrasound, how much strokes I added. And the cost also of the grease, I can log it to the software. Let's say, for example, I'm buying this grease by $1 for each 1 gram cost me $1, for example. I'm just saying, for example. So it will calculate for you how much saving every time you're greasing this bearing automatically. So talking in the money and talking about the ROI, yes, the ultrasound can help you also to see the ROI and the return on investment. We can see it in 2 ways. The first way, we can see it in the grease cost. For example, in this plant in March 2017, they saved $86 from grease cost. Yeah, I know it's not a big deal. It's just a peanuts, but just imagine with me that we have in the past, we used to have to add 5,550 strokes inside our bearings. However, we added only 247 strokes. Can you imagine with me about 95% decrease in the grease tasks? How many manpower we saved here as well? We saved thousands of manpower, and also we increased the protection of the equipment. We added accurate lubrication for our bearings. We reduced the maintenance cost. We increased the profitability. We added the right lubricant volume per point. We increased the asset reliability and availability. So the cultural change also, if we are talking about over greasing and lack of greasing, cultural change is very important and crucial. So adding ultrasound will help you a lot to get out the most of your resources and decrease the downtime and increase the bearing reliability and availability. But first, we have to follow if you are following the same culture, which is we have still lubrication contamination problems, and the lubrication guys or the lubrication loop techs are not trained well. So you're just wasting your time and money. So basically, culture is very important, and the cultural change is very important. I have to take the lubrication program as a program, not just as procedures to follow in lubricating the bearing with ultrasound only. No, it's a complete program, starting from the cleanliness and how to avoid the contamination, and how to get a calibration for our metered grease gun, how to use also remote access sensors for the non-accessible bearings, how to make sure that I'm testing the bearing in the same time and sorry, in the same location every time using the same module or in the same sensor with the same frequency settings, and also select the right person to make sure that he's trained. These guys are very important who are doing the lubrication for our bearings. They can control the bearing life. So they understand the importance of the proper lubrication to the reliability of the assets. They have been given a clear instructions and procedures for how the assets will be greased and how the ultrasound instruments are used. Consider updating, rewriting lubrication PMs to reflect the use of ultrasound. So just now I finished my presentation. I'll just give you a quick brief about the latest trends of the ultrasound technology and the condition-based lubrication in the world. So in the past, we used the portable devices for monitoring and for listening to our bearings and greasing the bearings ourselves. In 2021 and 2022, we start to launch a new technology which called the on-track smart loop, which can help to do the same while you are in your office, in your home, everywhere. You can monitor and lubricate the bearing, not time-based, condition-based as well, using the on-track smart loop solution. So basically, the on-track smart loop solution consists of a remote bearings, remote sensors to be mounted on the bearings, and the remote cartridges as well with the specific amount of grease. So I'm making sure that I'm adding the right lubricant volume without any contamination as per the bearing demand, not as per a timesheet or as per the time change in the time, just following the change in the decibel value. So I'm making sure that once the bearing asks for grease, I'm following the friction of the bearing. Once the increase of the decibel value increased by 8 decibel, at that time I will add lubrication while I'm in my office. So no need to go again to the plant and lubricate your bearing using the old method. You can use the condition-based lubrication, the automatic one. So this is basically, we are following the same alarm levels. We can monitor remotely monitoring the bearings and also lubricate the bearing as per the bearing demand. So we can see the baseline for our bearing. We can see the lubrication alarm, and why lubrication alarm in blue, not in yellow, not in red, because it's a proactive alarm. We don't have a failure yet. And once I see the increase above this lubrication alarm, I can lubricate my bearings remotely and start to see the change in the decibel value as well while I'm in office, in home, anywhere. So let's take a case study also of using the latest ultrasound technology condition-based lubrication in one of the rotating equipment. So basically, as I was discussing with you, so we can see this blue line is the green line is the baseline, and the blue line is the lubrication alarm, and the yellow one is the friction alarm, and the red one is the critical alarm. So we can say, like, for example, the baseline dB, the lubrication alarm will be 8 decibel above the baselines, and 16 decibel above the baseline, and 35 decibel above the baseline. So this will be our alarms. So easily we can connect the cartridge and the sensor to the on-track, and we can do the same job while we are not in the field. So this is an interesting case study. I will show it to you now. During monitoring and greasing one of the bearings, we noticed that the bearing decibel value increased, and once we lubricated the bearing, the decibel value decreased. After some hours, it started to increase again. We added some lubricant, decreased. After some hours, it started to increase again, increase, even to the maximum. We greased the bearing, it decreased, increased again, decreased, and so on. So this is what we call it the Panadol effect. The same, I'm just adding a Panadol to the bearing, but the problem already is there, and I have to address this kind of problem, and I have to go deeper and see what kind of failure I'm having in my rotating equipment. That's why, and in 2024, this is the latest technology which we have. We call it the on-track complete solution. The on-track complete solution, which can help me to make the same job remotely, wireless. The sensor also will be wireless, and also the cartridge will be wireless. And I can monitor the bearing lubrication, friction, ultrasound, vibration, all, even the temperature and the RPM as well. So it will be a complete security for the bearings. So I can know the early stage bearing defect. I can also detect the bearing mechanical defect and bearing impacting severity. Since I can detect the crest factor, I can see also the kurtosis. Also, I can see the lubrication faults, since the ultrasound sensor already will help me to see the change in the decibel value. Also, I can detect the misalignment and mechanical looseness, imbalance, and belt issues, since I have also a vibration sensor in the same sensor. So this will be not only an ultrasound sensor, it's an ultrasound and vibration sensor as well, and temperature as well. So this new sensor can help me to detect the friction, impacting, vibration, can help me to see the velocity, acceleration, speed, and to see surface temperature as well. So this is the latest trends in the bearing monitoring and lubrication in the market. I just wanted to keep also my presentation updated with the latest trends from UE Systems. Thank you very much for attending my presentation. And if you have any question, don't hesitate to contact me. This is my email address. My LinkedIn account is Ahmed Moataz. You can feel free to contact me anytime. Thank you very much for your time and hope to see you again. And I want to thank also MDI and Salahatiyya for giving me this opportunity to join this meeting with you and present this technology. Thank you very much. Have a great day. Thank you.